हेलो एवरीवन, स्वागत है आपका यूनिवर्सिटी एकेडमी यूट्यूब चैनल में। आज के लेक्चर में हम लोग डिस्कस करेंगे सीरीज रेजोनेंस टॉपिक। अगर आपको इस टॉपिक के हैंड रिटन नोट्स चाहिए तो लिंक जो है वो डिस्क्रिप्शन बॉक्स में गिवन है, आप वहां से जाकर डाउनलोड कर सकते हैं। एंड वीडियो अगर आपको अच्छा लगे तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें। नाउ लेट अस सी what is resonance. For the occurrence of resonance in any system, two energies are required, and in an electrical network these two energies are provided by the inductor and the capacitor in the form of magnetic field and electric field respectively. So it means अगर हमें resonance चाहिए then we require at least two energy storage elements present होने चाहिए network में, and we know that energy storage elements are inductor and capacitor. So if a circuit consists of only resistance then there will be no resonance, and सिर्फ अगर इंडक्टर है तब भी रेजोनेंस नहीं होगा। तो इंडक्टर एंड कैपेसिटर दोनों प्रेजेंट होने चाहिए, एंड वी नो दैट इंडक्टर स्टोर द एनर्जी इन द फॉर्म ऑफ मैग्नेटिक फील्ड, एंड द अमाउंट ऑफ एनर्जी stored in the inductor it is given by half of L into I square. Similarly, capacitor it store the energy in the form of electric field, and the amount of energy stored in the capacitor it is given by half of C into V square. Okay, and let us see what is resonance. So जो resonance है, it is a condition when the voltage across the circuit becomes in phase with the current supplied to the circuit. So when the resonance occur then the voltage and the current it will be in phase. So suppose अगर ये voltage phasor है then current it will also be in phase with the voltage, and the angle that is phase difference is 0. So what is power factor? That is cos phi, and phi value is 0, so cos 0 is 1. So it means we say that power factor is unity at resonance. Okay, so at resonance the circuit behave like a resistive circuit, because we know that in case of resistive circuit the voltage and current they will be in phase. Okay, so in pure resistive circuit voltage and current क्या है, in phase है. So that is why it will be a pure resistive circuit, and the power factor of the circuit at the resonance is unity. So because मैंने बताया कि voltage और current क्या है, in phase में, तो दोनों के बीच में जो phase difference है वो phi की वैल्यू क्या है, 0, and cos 0 is 1. So that is why the power factor of the circuit at resonance is unity. Now let us see what is resonating frequency. So resonating frequency it will indicate the rate at which the energy transformation takes place between the inductor and capacitor. As the circuit consists of energy storage element like inductor and capacitor, so they are connected in circuit. So during one part of the cycle the inductor will supply the energy to the capacitor, and then capacitor will get charge, and then after that the capacitor it will supply the energy to the inductor. So this is the known as resonating frequency. It is define the rate at which the energy transformation, that is from magnetic energy to electric energy, magnetic energy to electric energy, and vice versa. Okay, now the resonance it is of two type. One is series resonance and other type is parallel resonance. So आज के lecture में हम लोग discuss करेंगे series resonance, and in the next lecture we will cover parallel resonance. So now let us see what is series resonance. So in case of series resonance, here I have considered a series RLC circuit, because यहाँ पे क्या है, series है. So I have considered a series RLC because we need resistance, inductor and capacitor, तभी resonance occur होगा circuit में. Now as they are connected in series, so series में we know that current will remain same. So when the resonance occur in the circuit, the voltage across the inductor it will be equal to voltage across the capacitor in magnitude. Okay, so दोनों का जो magnitude है वो तो same है, but they will be out of phase by 180 degree. So you can understand this by a phasor. So as they are connected in series, so current will remain same. So this is current phasor, I phasor. Now what is V of R? So VR is a voltage drop across the resistance, and we know that the in case of resistance voltage and current it will be in phase. So this is V of R, and this is in phase with the current I. Now what is VL? So VL is a voltage across the inductor. and we know that in case of inductor, current lag the voltage by 90 degree. So it means voltage VL, it will lead the current by 90 degree. So if it is leading, then we have to represent in the anti-clockwise direction. Okay, so this is V of L. Okay, now we can see that यहाँ पे क्या है, current जो है वो voltage से lag कर रहा है by the 90 degree. Okay, so this is VL phasor. Similarly we can draw V of C. So in case of capacitor, current जो है वो voltage से lead करता है by the 90 degree, or we can say that voltage it will lag the current by 90 degree. So this is the phasor for V of C. So now when the resonance will occur in the circuit, so V of L का जो magnitude है and voltage across the capacitor, इनका जो magnitude they are equal, but they will be out of phase by 180 degree. So they will cancel out each other effect, and the circuit it will be left will be purely resistive. Okay, so if mod VL is equal to mod VC, so what is mod VL? That is voltage across the inductor. It is given by mod of I into X of L, and similarly voltage across the capacitor, it is given by I into X of C. So X of L is inductive reactance and X of C is capacitive reactance. So current it will get cancelled out because it is connected in series, and series में क्या है, current same होगा, so it will get cancelled out. So now we are getting XL is equal to X of C. So this is the condition to occur the resonance in a series RLC circuit. Okay, so this is the condition for the resonance in series RLC circuit. It means when the inductive reactance it is equal to capacitive reactance in magnitude, then the resonance will occur. It means then our circuit will be purely resistive, and in case of purely resistive, voltage and current it will be in phase. So now let us see what will be the impedance at the resonance. So as X of L is equal to X of C, so this imaginary part of the impedance it will become zero, because we know that series RLC case में जो impedance है it is given by R plus J XL minus XC. अब जब resonance होगा तो XL और XC की वैल्यू क्या है, equal होगी. So this imaginary part it will become zero. So now we are getting the impedance value, that is Z, it will be equal to R. This indicate that the circuit will be purely resistive. Okay, so circuit will be purely resistive at resonance, and if the circuit is purely resistive, power factor it will be unity. So we can write unity power factor, and also voltage and current phasor they will be in phase. Okay, so during the resonance circuit is purely resistive. It means this inductive reactance and capacitive reactance they will cancel out each other effect, so the circuit will consist of only resistance. So यहाँ पे क्या है, circuit में क्या है, सिर्फ resistance बचा. So it means we can say that it will offer minimum impedance. So at resonance, in case of series resonance I'm talking about, impedance will be minimum and its value will be equal to R, because क्या है कि जो inductive reactance है and capacitive reactance they will cancel out each other effect. So circuit में सिर्फ resistance बचा and it will be minimum impedance offered by the circuit during the resonance. So you have to remember this point also. Now let us see some curve. Now let us see mod of Z versus omega characteristics. So we know that in case of series RLC circuit, impedance it is given by R plus J X of L minus X of C. So X of L is the inductive reactance, so this is R plus J. X of L it is equal to omega into L, that is inductive reactance, and X of C is capacitive reactance given by 1 by omega into C. So now if we calculate the magnitude of Z, then it will be given by square root of real part square, that is R square, plus imaginary part square is omega L minus 1 by omega C whole square. So now using this relation we can find out how the magnitude of the impedance is varying with respect to the frequency. So उससे पहले, this is the first curve. Here we will see the how the reactance, this is X, means how the reactance is varying with respect to the frequency. F भी कह सकते हैं, और also you can write omega, because we know that omega, that is angular frequency, it is given by 2 pi f. So we can say that omega is proportional to f. Okay, so now we know that in case of capacitive reactance, that is, first of all we will see for inductive reactance. So this is the curve for x of l, because we know that inductive reactance, it is given by omega into l. So x of l, it is proportional to omega. It means inductive reactance is directly proportional to frequency. So this is the curve for x of l proportional to omega. Now we will see for x of c, it is given by 1 by c omega. It means capacitive reactance, it is inversely proportional to the frequency. So this is like this, because अगर omega increase हो रहा है, then x of c value will decrease. So this is the curve, and both these points, it will intersect here. So here the inductive reactance and capacitive reactance, they are equal in magnitude. Okay, so now if we see after this point, okay, so if we see here, suppose this is first and this is second. So if we see in the region 1, so this is the curve for x of c. Okay, so this is the curve for x of c and this is a curve for x of l. So before this point, that is in the region 1, x of c value, it is greater than x of l. So we can say that before the resonance frequency, that is below fr, our capacitive reactance, it is greater than inductive reactance. So if xc value is greater than x of l, then the circuit, it will have a leading power factor. Okay, and if we see in the region 2, that is above the resonating frequency fr, this is x of l. Okay, and this is x of c characteristics. So we can clearly see that x of l value is greater than x of c in the region 2, that is above the resonating frequency. Inductive reactance is greater than capacitive reactance. So if inductive reactance value is greater than capacitive reactance, then the circuit will have a lagging power factor. Okay, here it will have leading power factor, and exactly at this point where both these curves are intersecting, it will have, that is at the resonating frequency, it will have unity power factor. Okay, and the circuit will be purely resistive. So now we can see the curve for the impedance. So इसी कर्व को अगर हम कंबाइन करें, देन वी विल बी गेटिंग दी characteristics of impedance with respect to the frequency. So you have to draw a curve like this. Okay, so this is the curve, and at this point, that is here, you will have unity power factor. Okay, it means the circuit will be purely resistive and the frequency is given by resonating frequency. So at this point, inductive reactance, it will cancel out the capacitive reactance effect. So circuit purely resistive hoga, and impedance, it will be minimum. So that is z minimum value, it is equal to r, and below the resonating frequency, capacitive reactance is greater than inductive reactance. So circuit will be capacitive in nature. So it means it will be of the nature r of c. It means it will have the leading power factor. Okay, and above the resonating frequency, the inductive reactance value is greater than capacitive reactance. So it means the circuit will be r of l, and it will have lagging power factor. Okay, so you have to remember this 2 point, that in case of series RLC circuit, below the resonating frequency, the circuit will behave capacitive in nature and it will have leading power factor, and above the resonating frequency, it will behave inductive and it will have the lagging power factor. Now let us see how the current is varying with respect to frequency. So we know that current, it is given by voltage by impedance. Okay, so we can say that this current, it is varying inversely with respect to the impedance. So now we have seen the impedance characteristics with respect to the frequency. So this is omega and this is z. So it was like this. So यहाँ पे क्या है कि and current and impedance, they are inversely related. So अगर impedance with respect to frequency is this, so जो current है इसका जो waveform है, it will be just opposite to that. So it will vary something like this. Okay, so this is the waveform of the current with respect to the frequency f or omega, you can write. Okay, so now here at the resonance, so this is the frequency where the resonance is occurring, that is known as a resonating frequency. Okay, so at the resonating frequency, the circuit will have minimum impedance and value is given by r. So if impedance is minimum. Okay, so if impedance is minimum, this implies that current will be maximum in the circuit, and the value of maximum current, it is given by V by R. So you can see that at this point, that is at the resonating frequency, current is maximum, and the maximum value of current, it is given by V by R. And below this frequency, that is below the resonating frequency, the circuit, it will behave capacitive and it will have leading power factor, and the value of current in this zone is given by I is equal to voltage by the Z of C. Okay, that is capacitive impedance. And above this resonating frequency, the circuit will be inductive in nature. Okay, and it will offer lagging power factor. Okay, this is capacitive in nature. And the value of current here, it is given by V by Z of L. So this is the current varying with respect to the frequency, and you have to remember this I maximum value, which is given by V by R. Now let us summarize all the points. So these are the conclusion for series resonance. Okay, so these are for the series resonance. So by default, अगर क्वेश्चन में कुछ भी मेंशन नहीं किया है कि वो सीरीज रेजोनेंस है या पैरेलल रेजोनेंस है, then by default you have to consider the resonance as series resonance. Okay, so first point is for omega less than omega naught. So omega naught is resonating frequency. You can also write omega of R. Okay, you can use anything. This is resonating frequency. So if frequency is less than resonating frequency, the capacitive reactance is greater than the inductive reactance, we have already seen. So it means X of C, it is greater than X of L, and that is below the resonating frequency, and the net reactance is capacitive in nature. Therefore current, it will lead the applied voltage, because we know that in case of capacitive circuit, current, it will lead the voltage, and as a result of which the power factor is leading in nature. Okay, and then at omega is equal to omega naught, that is at the resonating frequency, both the reactances are equal in magnitude. It means inductive reactance, it is equal to capacitive reactance, and the net impedance is purely resistive, because जो रिएक्टेंस वाला पार्ट है वो जीरो हो जाएगा, बिकॉज इंडक्टिव रिएक्टेंस एंड कैपेसिटिव रिएक्टेंस वो दोनों एक दूसरे के इफेक्ट को कैंसिल आउट कर देंगे, एंड द इम्पिडेंस इट विल बी मिनिमम. ओके, एंड एज द इम्पिडेंस इज रेसिस्टिव, therefore the source voltage and the source current, they are in phase, and hence the power factor is unity. Okay, so this is at the resonating frequency. And the third point is for omega greater than omega naught, that is above the resonating frequency. Okay, so above the resonating frequency, this is for below the resonating frequency. So above resonating frequency, the inductive reactance effect is greater than the capacitive reactance. It means XL value, it will be greater than X of C. So the net reactance होगा circuit का, it will be inductive in nature, and we know that in case of inductive circuit, current will lag the applied voltage, and as a result of which power factor जो होगा वो lagging nature का होगा, because circuit is inductive in nature. Okay, so now let us see what is the formula for the resonating frequency. So we have seen that at the resonance, inductive reactance magnitude, it will be equal to capacitive reactance magnitude. So what is X of L? It is given by omega naught into L. It is equal to X of C, it is given by 1 by omega naught into C. So if from here, if we calculate omega naught square, it will be equal to 1 by L into C. So from here we are getting omega naught, or कुछ बुक्स में you will find omega of R notation. So this is given by 1 by root L into C. So if this is, then unit is radian per second. So this is the formula for the resonating frequency, which is a very simple formula, and unit are radian per second. But if you have to calculate the resonating frequency in hertz, then we know that omega, it is given by 2 pi f. Okay, so this f of r, it will be given by 1 by 2 pi root L into C. So this is the formula of the resonating frequency in hertz. Okay, so I have written the same formula here. So f of r is the resonant frequency in hertz, L is the inductance in Henry, C is the capacitance in Farad, and pi value is 3.14. Now let us see what is quality factor. So, definition of quality factor is it is a maximum energy stored in a circuit to the energy dissipated in the circuit per cycle of oscillation. So quality factor का जो formula है, this is a generalized formula for the quality factor, which is equal to 2 pi into maximum energy stored in the circuit divided by energy dissipated in the circuit in one time period. Okay, so if you find out what is the maximum energy stored in the circuit, so it is given by omega of m. So omega m here, it is indicating maximum energy stored in the circuit. Okay, so now circuit, because resonance circuit is, so it will consist of inductor and capacitor, and these two are the only ones which will store the energy. So energy stored in the inductor, it is given by half of L into I square. Similarly, the energy stored in the capacitor, it is given by half of C into V square. Okay, so now if we let the current expression I of t, it is given by Im sine omega into t. This is sine. Okay, so sine omega into t. Then what is voltage across the capacitor? So voltage across the capacitor, it is given by the formula 1 by c integration of I of t into dt. So this will be equal to 1 by c integration. So what is I of t? That is given by Im sine omega t into dt. So now if we integrate this term, so we are getting I of m by c. Integration of sine omega t is minus of cos omega into t, and again integration of omega into t is omega. So this is the term we are getting after integrating Im sine omega t. So now we can write omega of m as, so this omega m, now it will be equal to half of L I square. So now if we square this I of t expression, we are getting Im square sine square omega into t, then plus we have half of c, and what is v square? So v is the voltage across the capacitor, so this is given by minus of I of m by omega into c into cos of omega t whole square. Okay, so now let us expand this term. We are getting, so omega of m, it will be equal to half of L into, this is Im square. Okay, so Im square sine square, so half of L into Im square sine square omega into t. Then we have, so if we square, then this minus sign, it will become plus, so we have half of Im square by omega square. So this is c square, and here we are having c, so this will get cancelled out. Okay, so we are getting plus half of 1 by omega square into c into Im square, and then we have cos square omega into t. Okay, so this is cos square omega into t. So now as we know that resonating frequency, it is given by 1 by root L into c. So squaring on both the side, we are getting omega square as 1 by L into c. So from here, if we find out the value of 1 by omega square into c, so this will be equal to L. So we will substitute this value here. Okay, so now we will substitute this value here. So we are getting omega m, that is maximum energy stored, it will be equal to half of L into Im square sine square omega into t plus half of, now this will become L into Im square cos square omega into t. So now we can take half of L into Im square common, so we are getting sine square omega into t plus cos square omega into t. So we know that sine square theta plus cos square theta, it is equal to 1, so this will be equal to half of L into Im square. So this is the maximum energy stored in the circuit. So now we can find out the quality factor. So quality factor, it is given by 2 pi into maximum energy stored in the circuit, which is omega m. It is given by half of L into Im square divided by energy dissipated in the circuit in one time period. So we know that energy dissipated, it is given by power into time. Okay, so जो energy dissipate होगी वो in case of series RLC circuit, because inductor and capacitor, they are energy storage elements, so they will store the energy is dissipated only across the resistor. Okay, so this is the energy dissipating element. So the energy dissipation is given by power into time, and the power across the resistor, it is given by I square R into T. Okay, and by default we have to consider the RMS value of the current. So what is the RMS value? In case of sinusoidal signal, RMS value is given by maximum current by root 2 square into R into time period is suppose T. Okay, so it means the energy dissipation formula, it is given by Im by root 2 whole square into resistance into T. Okay, and also we know that this time period, it is given by 2 pi by omega. Okay, so omega is resonating frequency. So in place of T, if we substitute 2 pi by omega and simplify it, then we are getting, so we are getting quality factor as 2 pi into maximum energy stored in the circuit, it is given by half of L into Im square divided by, so this is the maximum energy stored in the circuit, then we have Im by root 2 whole square into R, and time period is 2 pi by omega, that is resonating frequency. So this will be equal to, this will get cancelled out, that is pi into L into Im square. This will be equal to Im square by 2 into R into 2 pi by omega. Okay, so this 2 will get cancelled out, this Im, it will also get cancelled out, this pi will get cancelled out. So simply we are getting quality factor as omega L by R. So what is omega L? That is inductive reactance by R. So this is the formula, one formula of the quality factor. Okay, so in case of series RLC circuit, अगर आपको quality factor calculate करना है, then you can simply take the ratio of inductive reactance to the resistance, and you can find another formula also. So we know that the quality factor, it is equal to, so this omega is resonating frequency, and in case of series RLC circuit, this omega is given by 1 by root L into C into L by R. So we can simplify this further, it will give 1 by R root L by C. So this is another formula. Okay, so this is first formula, this is second formula. Also we know that at resonance, so let me write, at resonance inductive reactance, it is equal to capacitive reactance. So from the equation 1 we can write that quality factor, it is equal to x of L by R. It can be written as x of C by R. What is x of C? Capacitive reactance, so that is 1 by omega into CR. Okay, so this is another formula, so we can write this as third formula, and we can derive some more formulas. Okay, using this relation only. So we know that this quality factor, it is given by x of L by R. So numerator and denominator mein if we multiply current, then we are getting I into x of L by I into R. So this is, what is I into XL? That is voltage drop across the inductor divided by the voltage drop across the resistance. Okay, this is fourth formula. Similarly, we can find out the quality factor formula. So if we multiply current, so here in the numerator and the denominator, so this is given by I into x of C by I into R. So I into x of C is given by the voltage across the capacitor by voltage across the resistance. So this is fifth formula. Okay, so now let us summarize all these formulas. So in short, the quality factor formula, it is given by, so this is for series resonance. Parallel के लिए you have to just reverse this formula. Okay, so in the next lecture we will see that formula, but in this, the quality factor in case of series resonance is, it is given by 1 by r root L by C. It is also equal to omega naught is a resonating frequency, L by R and 1 by omega naught. So it means we can write it as x of L by R, that is inductive reactance by resistance, or capacitive reactance by resistance. This is also equal to voltage drop across the inductor by voltage drop across the resistor, and voltage drop across the capacitor by voltage drop across the resistance. So all these formulas, you can use any of these, okay, depending on the data given in the question. So but all these formulas are very important. Okay, now let us see next topic, and this is bandwidth. Okay, so what is bandwidth? The bandwidth of the network represents the range of the frequencies at which the current drawn by the network become 0.707 of its maximum value. So 0.7 means 1 by root 2. So we have seen the waveform of the current with respect to the frequency, it was like this. Okay, so now this is the resonating frequency where the current is maximum. Okay, so this is maximum current and it is given by V by R. Okay, so this is maximum current and it is occurring at the resonating frequency. Suppose this is omega naught. Okay, so in terms of radian per second I am writing with omega naught, and in terms of hertz you can write f of r. Okay, so now if we consider that is 0.707, so 0.707 of the maximum current, so 0.707 is 1 by root 2 of maximum current, so it will come somewhere here. So हम ये भी कह सकते हैं 3 dB less है, so 1 by root 2 in decibel it will be equal to 3 dB less. Okay, so 0.707 of the maximum current is this point. So if we see the intersection of this point with respect to the waveform, then we are getting 2 points on the x-axis. Okay, that is on the reference axis. So this is f of L is lower cutoff frequency, and this fh is indicating the upper cutoff. This is upper cutoff frequency and this is lower cutoff frequency. Suppose this is omega 1 in the radian per second and this frequency is omega 2 in the resonating frequency. So now what is the relation between, so what is bandwidth? So bandwidth is defined as the range of frequency at which the current drawn is 1 by root 2 times of the maximum value. It means bandwidth formula, it is given by upper cutoff frequency minus lower cutoff frequency. Also we can write omega 2 minus of omega 1. So this is the formula of the bandwidth in radian per second. Okay, now if we have to see the relation between omega naught, omega 1 and omega 2, so omega 1 is lower cutoff frequency, omega naught is the resonating frequency, and omega 2 is the upper cutoff frequency. So the relation between these three is that this omega naught, that is resonating frequency, it is a geometric mean of lower cutoff frequency and upper cutoff frequency. Okay, so relation between, so relation between resonating frequency, okay, resonating frequency, that is omega naught, and half power frequency. So omega 1 and omega 2, they are known by half power frequencies, that is omega 1 and omega 2, because at omega 1 and omega 2 the power level in the signal is half of the maximum power, so that is why it is known as half power frequency. It means the frequency at which the power is half of the maximum value. So the relation between these two, it is given by omega naught, it is given by geometric mean of omega 1 and omega 2. Also we know that omega naught, it is equal to 1 by root L into C. Okay, so simply we can remember this formula. So from here we can also develop, so if we square on both the side, we are getting omega 1 into omega 2, it is equal to 1 by L into C. Okay, So we have seen that bandwidth, it is given by upper cutoff frequency, that is omega 2 minus of lower cutoff frequency. So it is given by the formula R by L. You have to remember the units also. Okay, so bandwidth formula is the range of the frequency. It means omega 2 minus of omega 1, it is given by R by L in the radian per second. And another formula is bandwidth, it is given by, in terms of hertz, it is given by f2 minus f1, it is given by R by 2 pi L. This is in hertz. Okay, so this is the formula for the bandwidth. Now if we see the relation between bandwidth and quality factor. Okay, so now let us see the relation between bandwidth and quality factor. So this is given by the formula. Okay, let me choose this pen. So bandwidth, it is given by omega naught, that is resonating frequency, by quality factor. Okay, so this formula is important and it gives the relation between bandwidth and quality factor. Okay, so this is also important and this formula is also important. सो आज के लिए इतना ही. नेक्स्ट लेक्चर में हम लोग डिस्कस करेंगे पैरेलल रेजोनेंस. एंड वीडियो अगर आपको अच्छा लगे तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें. थैंक यू फॉर वॉचिंग.